Okay, in reviewing for the test that you'll be taking, make sure that you do your definitions because these definitions are going to appear on the multiple choice section of the test. This test is going to be part multiple choice, part write out. So the definitions will be multiple choice. So you need to do them for a grade, but you also need to do them so that you will know them for the test. Now, if it says something about one of these in the to know section, that means it's on the test because I make up the test first and then I make up the review. So you need to know the general shapes of the sublevels, S, P, D, and F. Remember, there's an extra credit opportunity here if you can draw that alternate structure, the ones that look like they have little floaties on them. So you have to draw the 4 parts that I talked about, the 4 different sublevels that I talked about in the notes, but you can also get extra credit for the other 2. 90% probability rule, where we draw the line around the atom, remember that. Now this one encompasses multiple questions because there'll be a question about Bunsen, Schrodinger, Heisenberg, Becquerel, the Curies. There will be multiple questions about those individuals. So make sure you know what their contribution is. Some of that information comes from the beginning of the notes, the part that you did the packet over. Some of it is over the last set of notes that I did not do a video over. So make sure you know what those individuals did. The principles behind neon lights, fluorescent substances, and glow-in-the-dark substances. There will be questions about those, and they also are in notes 8-7. There's no video for those, but the write-out portion will tell you information about those things. Common equations to represent fission and fusion. Those equations are at the beginning of your notes, the packet portion. So make sure you know what a fission reaction looks like and what a fusion reaction looks like. I think there are 8 questions about this portion in the multiple choice section over this table. It won't be in a table form, obviously, but it will ask things like how many orbitals are in the S sublevel, how many electrons are in the F sublevel. So think of this as being the blanks on our orbital notation when you put 1 blank over an S, 3 over a P, 5 over a D, and 7 over an F. Think about these as being the arrows when you're looking at the number of electrons. So remember, each orbital can have an up and down spinning arrow. So make sure that you pay attention to the fact that you're doubling those values, the orbitals. So if it's an S sublevel, it'll have 1 orbital but 2 electrons, etc. So now the entire first page of the write-out is going to be a section like this. And it's going to be divided in a table form. So it's going to label each part, each block on the table and what you're supposed to put there. So you need to know that this is the orbital notation, that this is electron configuration, that this is the rare gas or abbreviated configuration. And finally, that this last one is the quantum number set. So make sure you get them in the right section on the test, but better to write them down than not to write them at all. And if you get them in the wrong section, at least you'll get credit for doing it correctly. I'll just take off a little credit for you not putting it in the correct block. Now, there will be one D4 or D9 element, one of the ones that if you listen to notes, and by the way, you can get all of this information. This was on 8-5 for the orbital notation. Electron configuration was 8-6A. Rare gas was 8-6B. So if you're wanting to go back and review some of that, you can. But when it talked about on 8-6B, at the end, it talked about D4 and D9 electrons as being an extra credit opportunity. So everywhere you see green here is someplace that you could get extra credit for. Now, if you left this one blank and you had 2 arrows in this one, you would have gotten full credit. If you had said this was 6S2, 5D9, you would have gotten full credit. Here again, 6S2, 5D9 would have been full credit. And if you did this that way, you would have gotten a -1 in this position. So all of that would have given you credit. But if you had the original green that was there, it would be extra credit in each one of those situations. So keep in mind that that's an extra credit possibility. The 4 quantum numbers, multiple choice section. So make sure you know those and pause this if you need to make sure and get those written down. Somewhere on your test, either on a scratch paper, on the back of your test or something, you need to be able to jot down this information with the order of the different types of electromagnetic radiation, the fact that this is the triple L side for low energy, low frequency, and long wavelength, because I'll ask you questions about which has the lower energy, red or violet light, which has the higher frequency, infrared or ultraviolet. And if you don't have this diagram written down, you won't know what you won't have any idea what the answers to those questions would be. This table, you might as well put a big smiley face by it, circle it, whatever you want to do, because that table word for word is going to be on the test, on the write-out portion, and you'll have to fill it in just like you did here. Make particular note of what I want these symbols to look like. Don't give me A's and B's and something that looks like a Y. This is a fish swimming to the left. This is like an italicized B with tails. Make sure those tails are there. And this is like a nose-diving fish, so make sure that information is there. The alpha particle, remember, is a helium nucleus, so this is what it would look like. The beta particle is just an electron, so it would look like this for a particle. And since gamma radiation is not a particle, it's just electromagnetic radiation, this is what a symbol for that particular type of radiation would look like. The charges, positive, negative, and neutral, for alpha, beta, and gamma radiation, and then their penetrating ability, low, moderate, and high. Please don't give me weird words like not too good, kind of, and it rocks, or something weird like that. Make it sound professional. Low, moderate, and high. I might accept medium here. I'm sure I would, but please give me things that sound, terms that sound at least professional, okay? So, for the nuclei symbol, I didn't fill these in yet because I wanted us to review it. Remember that when you make the symbol, you have the element symbol first. Down at the bottom is going to be the atomic number for zinc. And if you look up zinc on your periodic table, you will see that zinc is number 30, so its atomic number is 30. And once you know that, remember that 66 is protons plus neutrons. So that's the number that's going to go on top. That's 66. Now, as far as the number of protons and neutrons in samarium 149, remember we're going to look up samarium. If you look up samarium on the periodic table, you'll notice that samarium is number 62. That means it has 62 protons. And like I said just a moment ago, this number is protons plus neutrons, and that's the number that goes on top when you're writing the symbol. That also tells you that if we just simply subtract that 62, we're going to end up with 87 for our number of neutrons. Protons plus neutrons gives us that top mass number. As far as writing these radioactive decay reactions, remember you can put an equal sign here in the middle for the arrow. The top numbers have to add up. So if this is 243 and this is just a 4, then I need to have a 239 on top for this blank, so that 239 plus 4 gives us the 243. On the bottom, this is going to need to be 93, since 93 plus 2 is going to give me the 95 on the other side. Now, what element is that? Look on your periodic chart. Find number 93, and you'll see that number 93 is NP, Neptunium. And since this is the 4/2 He particle, you should know that therefore this is going to be alpha decay. For the next one, the top number is easy. Since this is a 0 over on the far right on top, the top number on this side is simply going to be the same as the top number on the left-hand side. It's the bottom number that everybody misses. I don't know how many times people put 90 on the bottom. But if you have 90 minus 1, that's going to give you 89. And that is not 89. So make sure you're paying attention to the fact that this is a negative 1. And that this number needs to be 92. 92 minus 1 gives you 91. And if you look on the periodic table and you see number 92, you'll see that that is uranium. And since this is the 0/-1 electron particle, this is our beta particle, beta decay. So that's how you do those particular types of problems. When you're looking at half-life, the best way to do half-life is to do a table. Start out with 0 for your time, a time of 0, and you've got an amount for your sample of 200 in this case. Okay, we've got this table going. And then the half-life is 1.5 seconds. And we're going to let it keep decaying for a total of 6 seconds. So we're going to go by 1.5s until we get to 6. So we've had 1.5 seconds. After another 1.5 seconds, we'll have 3 seconds will have passed. Another 1.5 seconds, 4.5 seconds will have passed. And finally, after another 1.5 seconds, we'll get to our total time of 6 seconds. And each time a half-life passes, remember, that indicates that half of our sample has decayed and turned into something else. So after 1.5 seconds, we'll only have 100 grams left. After 3 seconds, half it again, we'll only have 50. After another 1.5 seconds, we're only going to have 25. And finally, after our total 6 seconds have passed, we'll only have 12.5 grams of our sample left, and that's our answer. The next ones are just finding the information from some of the material we did in the packet. The legal dosage is 5 rems. For each week, it's 100 millirems of radiation. For unborn babies, there is no safe dosage. No safe dosage for unborn babies. In fact, that is where your greatest risk comes in, is for the unborn baby if it's exposed to radioactive materials, into any kind of radiation. Now, as far as these last 3 problems are concerned, you can pause it and make sure you're looking at these problems and working them out in your calculator to see if you get the answer that I got. Notice on this first one, the green part, we had to do the calculation first to change this into meters. It asks us to find the wavelength. That's what it's asking us to find, and it tells us that our frequency is 98.6 megahertz. Remember, frequency has to be in meters, frequency has to be in hertz or reciprocal seconds, which is why we had to do this calculation. So if I know I'm dealing with the wavelength and frequency, wavelength is lambda, frequency is this blocked off V. So those are the values. Once we know that it's dealing with wavelength and frequency from the problem, that's the equation that we're going to want to look for. Once I plug those values in, then hopefully you've gone through and looked at how that turned out in your calculator, and hopefully you got the answer 3.04 times 10 to the 0 if you wish to, but remember we can leave off the times 10 to the 0 part and just put 3.04 meters. So that's the first type of problem. The next problem tells us what the frequency is and asks us for energy. Again, you're going to be looking for the equation that has energy and frequency in it. Not only am I going to give you a paper that has the frequency, excuse me, that has all of these equations, but it's also going to have the constants as well. So you're not going to have to memorize what Planck's constant is, but you're going to have to recognize that it's Planck's constant and look for it on that sheet. So once we put those values into the equation, this one for Planck's constant and the value from the problem, and multiply those, check it out in your calculator, make sure you're getting 3.3 times 10 to the negative 20th for the joule value. For the final one, this one gives us the wavelength and it asks us for energy. Once again, we're going to be looking at the cheat sheet and we're going to find the one that has energy and wavelength. If you don't know what your wavelength and frequency symbols look like, then it's going to be a problem to find them on the worksheet. You get points just for writing those down. So the correct equation, more points for putting in the correct values, and finally, obviously, all points if you get the answer right. Now notice something, that as we did this, Planck's constant here and speed of light both are constants, so those values are automatically put in, but watch out for wavelength. Wavelength has to be in meters or it won't cancel. That's why we had to do this green part up here. I showed you in green and red how to convert, and reminding you how to convert from centimeters to meters. Since we went from 10 to the minus second on the unit to 10 to the 0, our unit went up by 2, so our number had to get smaller by 2. So it became 10 to the minus fifth instead of the original 10 to the minus third. So make sure you get those converted. And then plugging these into your calculator, guys, I cannot emphasize enough that you have to get these plugged in correctly. If you put in times 10 anywhere in your calculation, you're going to get the wrong answer. Make sure you're using your E button for times 10. Finally, also remember, you're not going to get to use your colored periodic table on the test. You will be given a blank periodic table. You can bring colored pencils, or I'll provide some, and you can shade them in really quickly. Just remember that over here, the S's start with 1. The P's over here on the right start with 2. The D's start with 3. And down at the bottom 2 rows start with 4F and 5, then comes 5F. So if you'll remember that it's 1, 2, 3, and 4, it will help you to get those labeled correctly on your periodic chart for the test.